Chengxi, 12 years old. For this lesson, we'll be continuing on with techniques and applications of the definite integration. For this lesson, we'll be applying the technique to double integral x, which is bounded by d here, and then x plus y dx dy, whereas d is bounded by x squared plus y squared is smaller or equals to 2, and x minus 1 bracket square plus y square is bigger or equals to 1. So as you can see, for this part, what we have here for the first part over here is basically, so for this part we're going to have the r square, right? So that means that the radius is going to be square root 2, as you can see here, which is marked out, and the center will be 0 at 0, whereas on the other hand, so for the larger circle this is the case, while for the smaller circle what we're going to have is that the center is going to be at 1 for the x-axis, which is somewhere over here. So for this part, what we're going to have is that the radius is going to be square root 1, which is 1, and since the center is at 1 for the x over here, it just so happens that for this part, it will be the small circle will be touching the 0 over here. Okay, so what we're going to have for this part is that you see these two circles, one larger and one smaller, right? And if you realize, so you can have these two lines for this, but what are the equations? So let me just tell you, for the red one, it's for the x squared plus y squared over here. Okay, well, for this part, what we have is that x minus 1 bracket square plus y square equals to 1. Well, what about these two lines? Well, for this line, you can tell that y is, so y over here, it is equals to x. So in case you who didn't know about it, so for this part over here, y is equals to x, while for this part it will be y is equals to negative x. Okay, so as you can see, for this part, if we are going to solve this, what we're going to have is that, so first of all, the boundaries. So over here, if you're wondering, so for x, so before I talk about that, so for x, it is equals to r cosine theta, while y is equals to r sine theta. So over here, what we're going to have is that bracket r cosine theta plus r sine theta bracket r d theta. Okay, but what is its boundary? So as you can see here, for this part, also if you're wondering why the y is equals to x and y is equals to negative x and all, well, it's because the intersection point for this part, it is 1. Okay, so yeah, that's why. So for this, what we have here is that, so let's see. So for the r, it is pretty obvious, it's just the radius over here being from 0 to square root 2. Then what about for theta? So for theta, as you can see for this part, we are supposed to find this crescent, right? But we're going to use this 3/4 of a circle, and then minus the shaded regions. So for this part, it will be from pi over 4 till 7 pi over 4. And then what we're going to have here now is that, and now that we have gotten this, we need to minus the two shaded regions. So for the two shaded regions, I'm going to write separately. So over here for this part, Okay, so first of all, what is the range for the theta? So the range for the theta is going to be from here to here. So, and it will be, so from here to here, it will be from pi over 4 to pi over 2. But what about its range? So its range apparently over here, if you have a semicircle for this part, and we are trying to find this length over here, what we are going to have is that, so no matter which semicircle, so the base over here is going to be 2 times of the radius, which in this case would be 2, right? And here we have theta. Yes, theta for the polar coordinate. So what are we going to get for this part? So for r over here, what we are going to get is, so as you can see, for this we'll have 2 cosine theta. So what we're going to have here is going to be 2 cosine theta no matter what. So over here it will go from 0 to 2 cosine theta. While over here now for the below part, what we're going to have is, so it's going to be from here to here instead, so it will become 3 pi over 2 to 7 pi over 4 instead. And now that we have gotten this part, the other boundary is going to be from 0 to 2 cosine theta again, whereas we're going to have the r cosine theta plus r sine theta r d theta. Okay, now that we have gotten this, so we can take out the r's apparently. So for this, what we're going to have is, like this. Well, for this, what we're going to have is that, like this. Well, for the denominator, it will be similar. Okay, so now that we have gotten this part, what we are going to have is that, so over here for this, you can clearly tell that we can already integrate for both of these, okay? So for this part, we can integrate and it will become, so cosine integration will become sine theta. Well, sine integration will become negative cosine theta. And you'll get from pi over 4 to 7 pi over 4. And then well, for this part, what we're going to have is 1 over 3 r cubed from 0 to square root 2. Well, for this part, we can only do for r for now because the boundary over here still has the theta. So what we're going to have is pi over 4 to pi over 2, and then 1 over 3 with the cosine theta plus sine theta, and then r cubed from 0 to 2 cosine theta d theta, and then minus and this is what we're going to get. And for our next step over here, so as you can see for this part, what we have is that, so sine theta, so what is sine pi over 4? So sine pi over 4 is, apparently for this part it will be square root 2 over 2, okay? So while cosine pi over 4 is half. So, I mean square root 2 over 2, sorry. So for sine 7 pi over 4, it will be a negative because it's at the fourth quadrant. So for this part, it will become a negative square root 2 over 2. Then this part you have minus. So you have minus square root 2 over 2. Because for this part it's minus, but over here sine pi over 4 is just square root 2 over 2. And here you have minus. So cosine 7 pi over 4, it will be positive. So minus square root 2 over 2, and then you minus, and then cosine pi over 4, it will still be positive, which will end up with so since this part is it's a minus, so negative will become positive, and you'll get square root 2 over 2. Well, for this part, what we're going to have is 1 over 3 times square root 2 square root 2. Okay, so 2 square root 2 over 3. And then now for this part, what we're going to have is 1 over 3. So apparently when it's 0, it just minus 0, so you can just straight up sub in this and you'll get so when you sub this in, what you're going to get over here is, so you have a 8, as you can see for this part, so it'll be 8 over 3, while for this cube, so it will be practically to the power of 4, and then sine theta cosine cube theta d theta, and then minus 8 over 3 pi over 2, 7 pi over 4, same thing. And now that we have gotten this part, what we're going to get here is, so as you can see, these two who you minus and you just get negative square root 2 times 2 square root 2 over, so for this part you're getting a negative square root 2, and if the times over here it will just become negative 4 over 3, okay? Well, for this part, what we're going to get is going to be, so you can separate this into two parts, where the first part will be and here you are minus 8 over 3 . Well, for this part, what we're going to get is, so over here you can put the sign inside and it will become plus, because sign integration is negative cosine, so plus cosine cube theta d theta, and then after that minus, similarly, so for this part it will be cosine theta, and then for this you have So for this, the 4/3 will stay there. Well, for this part, you may be wondering what I'm going to do with the cosine to the power of 4. So for this part, what we'll have is so apparently cosine square theta is over here 2 cosine 2 theta minus 1, and since there's it's to the power of 4, so here you bracket square. Okay, so for this part, what we're going to have is that wait, give me a sec. So apparently it's so 2 cosine square theta is equals to cosine 2 theta plus 1. Okay, and then after that over here for this part we can already integrate it, and you get, so for this is basically cosine, so 1/4 cosine to the power of 4 theta and then from pi/4 to pi/2. While for this part over here you're minus. So once again you use the same method and you get 2/3 pi 3 pi/2 and then 7 pi/4, and you have cosine 2 theta plus 1 bracket square d theta. And then after that for this part you'll get this. Okay, and then for this part what we're going to get is so for this part we're going to have so this you can expand it and you get okay, so over here you can simplify and you get 2, you simplify and you get 2 over here. So apparently for this, as you will add on, so 2/3, so apparently cosine pi/2 is basically So apparently cosine half pi is 0, so for this part, and then you have a minus over here, so cosine pi over 4 will be square root 2 over 2. Well, as you can see for this part, what we're going to have next is that, so we're going to have another one of these, so it will be and since this part is to the power of 4, so you have the to the power of 4 over here. And then for this part, you're going to get then after that for this part you okay, so apparently cosine 7 pi over 4 is square root 2 over 2, so you have the power of 4, while cosine 3 over 2 will be 0, while for this part, so as you can see here, so just take a quick look before I erase it. So for this, okay. So for this part, you have negative 4 over 3, and then for minus. So for this part, once again you can separate it. So for this first you have with the cosine square to theta, you can use it again and you'll get so here you will get cosine 4 pi plus 1, and I mean cosine 4 theta plus 1, so here you have and you have to, so for this it will be so for this part, so here you have the 2 cosine 2 theta. So the 2 over here can be moved to the d theta and you get d2 theta. And here you can minus once again. And then for this part you have so over here for this part, as you can see for this minus and this positive, you can practically cancel them out. And then you will have this part left, which is going to be And for this part, what you're going to have over here is that, so negative 4 over 3. And then for this part, what you can do is, so over here, when you integrate cosine, it's still going to be sine, but it will still be negative over here. So it will be sine 2 theta from, and the boundary is from pi over 2 to pi over 4. And then after that, what we'll have here is that so over here, apparently for this part, you can put together with this, which will become just 3 over 3, okay? Then you can continue on with this part, and apparently over here, you can combine with this. And then over here, you put them together, which will get just the pi over 4, 3 pi over 2, and then the 7 pi over 4. And then after that, over here, minus. Now we calculate for this part, we're going to have negative 4 pi over 3 minus 1 over 12 sine 4 theta, and then the boundary. And then for this part, you can integrate too. And then for this part over here, you will sub it in, so apparently sine pi is equal to 0, and sine pi over 2, it will be equals to 1, while over here for this part, what you're going to get is a plus 2 over 3, because that for this part you're going to have, so you'll get plus 2 over 3 because negative and the minus over here, so negative, negative, positive. Then for this you have the same thing. And then for this part over here, 7 pi over 4 down times 2 will be 7 pi over 2, which will become 3 pi over 2. And sine 3 pi over 2 is negative 1. So negative, negative become positive, become plus 2 over 3. And then for this part, what you're going to get here is another 0, because sine 3 pi is 0. And what you're going to get here is that 2 over 3 and 2 over 3 add together is 4 over 3, and then 4 over 3 minus 4 over 3 at the start is going to be 0. Well, for this part, you can just sub it in. So when you substitute this to be inside, what you're going to get is sine 2 pi, which is equal to 0. And then if you sub this inside, you're going to get sine pi, which is equal to 0. and we are going to get here negative pi over 2 plus pi over 4. Then for this pi it's already minus 12, and this is also minus 12. Sine 7 pi is basically here, so sine 7 pi over here it will become 0. Then sine 6 pi is also equal to 0. So you're left with this part, which is minus 7 pi over 4 plus 3 pi over 2. So if you realize over here for this part, what you have is that, so let me just write it on another place. So you're going to get, so as you can see for this part, these two minus will become negative pi. So these two minus will be like negative pi over 4, and then this one 6 pi over 4 minus pi over 4. So the answer we're going to get is negative pi over 2. And this is the result that we get. And thus through this question, what we get in the end is a negative pi over 2. So first we had the graph with a big circle and the radius of square root 2, and the small circle was the radius of 1, which is where at the center is 1 on the x-axis and 0 on the y-axis because of the x minus 1 bracket square. So for this, and then after that we had to use the 3 over 4 of the circle to minus the green shaded region and in order to get the crescent. Then after that over here, so in order to find the part of the circle, you'll have the double integration over here where the boundary, the radius is basically here just square root 2 from 0 to square root 2, while the angle is basically formed over here. On the other hand, for the green shaded parts, for this part, what you're going to have is 2 cosine theta because of the triangle within the semicircle. And as for this part, that's how we got the boundaries and all. Then after all, we just mainly use the fact that 2 cosine square theta is equals to cosine 2 theta plus 1, and then we integrated and all, and we got this answer. So this is what we get in the end. Last but not least, thank you for your watching.